Hello. Let me go over some of the problems on the test, okay? And in particular, those ones about areas and the volumes. So let me first start with the number 5. Find the area bounded by this parabola and from x minus 2 to x to the minus 3. So here's a graph. Basically, I'll ask you for sine area and the absolute area, sine area and the absolute area. And the sine area is just the integral from -2. Okay, here's -2 is a line over here from -2 all the way to 3. But the absolute area is the absolute value of this portion, which it actually has a negative values. Okay, if I were to integrate this just from -2 to -1 is negative. So that's why there's a negative sign over here, because that will turn this answer into a positive answer. Then you add it to the other integral 1 to 3 from here to here. And so you want the sum, absolute value sum of those two areas. So that's the absolute area. For number 6, here's the pictures. And so if I want to write out integral for the absolute area for number 6, it comes in 3 pieces. And so one of the piece is to, let me get a pen out here. Okay. And so here's a line -2. So the first piece, one piece is here, and then there's a middle piece, and then the third piece. That's why you have those 3 integral. And depending on which on top, which is on bottom, you integrate the subtract top minus the bottom to get the value of the absolute value of the integrals. Then number 7, from here on, you have to be able to draw one of the exercises you have to be able to do for number 7 is that you have to be able to draw parabola second degree equations without much problems. And because a lot of problems that for this area problem, the example will be done by second degree equation because they are solvable. You can solve for the corners and stuff like that. So for number 7 in particular, here I'm not showing over here. Here we go. Number 7, go up a little bit. Okay. Well, okay. Anyway, for number 7, there we go. For number 7, you have to solve for the boundaries of the parabolas. And so in particular, if I want to solve this parabola, let me label the blue color. Here it comes, the blue. Okay. And that's y go to 4x minus, oops, this is label the wrong one. Okay. That's kind of bad. All I'm trying to say over here is 4 minus 1. All I'm trying to say is for this parabola right here, I want to solve for this piece right here. Well, turn blue, okay. And to solve for that, I need to use the quadratic formula, okay. And then you get plus minus. And the -1 is one on the other side. So I want a +1. That's how I get the right-hand portions of the formulas x coordinate in terms of y. So you should be able to solve for the boundary for second degree equations. Okay. Same thing over here. Actually, these are simpler versions that it solve for x in terms of y, y in terms of x. And then the other things you have to solve for the intersections. You find out the intersection over here turned out to be 1/2, 1/2. Okay, so here's point, and I'll leave that up to you. That point's 1/2, 1/2. So the integral, the limits were from 1, 0 to 1/2, 0 to 1/2. Okay, the problem is symmetric, so the answer is symmetric. Okay, so row X and Y play can be reversed. Number 9. Number 9, in order to get a washer, the slice I'm taking must be a horizontal slice. In other words, you're taking a thin slice of the solid, and that's based on dy. So the integral must be dy. So y goes from the 2 to 4, the height 2 to 4. Okay. Then you try to express the big radius, the little radius, in everything in terms of y. Okay. That's a big radius, and that's the equation. You have to solve for the equation of for the line. Then you then use that to figure what the big radius is and the little radius. For number 10, do the same thing with cylindrical shell. These you can do it in X or Y. So the answer I provide is given in following X. I take a very thin slice of X, dx. That's what dx thin slice. I follow it. It's a cylinders, and then the height of it is this formula. Equation of the line minus 2, and the radius of the cylinder is from here to here, and that's right here. Okay, and that's 2 pi rh integrating that. And finally, the Cavalieri theorems problem is crossing perpendicular to the y-axis. In other words, and this is the things we slice the solid with, perpendicular to the y-axis, then that's a square. And you find that you have to solve this side in terms of y, and it turns out it's twice of root y, and the squaring that is 4y. Integrate that, color everything. Okay. These problems will be our next test 2 again. So if you feel comfortable with this problem, then you're sitting well with the next test. And these problems will be next test, third test. They will be slotted in throughout the future tests over and over again. Okay, that's it. Bye-bye. Stop.